right, so now that we've talked a little bit about what hypothesis testing is, we're going to start digging in just a little deeper. So the first thing we're going to need to be able to do is actually write out what the null hypothesis and what the alternative hypothesis are for a test. So basically, define your test, okay? And that's very important that you are able to do that, especially as you're doing statistical research. So in this case, we're going to determine the null and alternative hypotheses, and then we're going to state which type of test this is. And I know that doesn't mean anything to you right now, but it will in just a second. All right, so according to Reader's Digest, in 1995, a study showed 9.5% of U.S. adults suffer from a depressive illness. A researcher believes that today this percentage is now higher than in 1995. Okay, so first thing we need to do is figure out what the null hypothesis is. So write out the symbol for the null hypothesis, and then you always follow that by a colon. So like saying this is what it is, okay? So what is it that is our historical claim or our historical value or something that like because of what's been happening in the past, we believe to be true, okay? So what we know right now, or what we think they know, is that 9.5% of adults suffer from a depressive illness of some sort, okay? That is a percentage, and so the symbol we use for a percentage or a proportion is P, okay? And so we think that P equals 9.5%. Now, because we're writing as a proportion, I'm going to go ahead and write this in decimal form, 0.095, okay? That's our null hypothesis. Now we're going to go to our alternative hypothesis. So that's H sub A, and again, follow it by a colon. And so now what we're going to say is, what do we think? What does this researcher think is the case, okay? Well, the researcher believes that today this percentage is higher, okay? That's what this person believes and is trying to prove. So what does that mean in terms of P and its relation to that 0.095 or 9.5%? This researcher believes that that number is larger than 0.095, okay, or higher than 9.5%. So that is the null and the alternative hypotheses. That's what they're trying to prove, okay? Now, in terms of what kind of a test this is what is considered, right? Sorry, that was the mailman. Little pause there to let Teddy do his thing. This is what is known as a right-tailed test, okay? A right-tailed test. That is because we think the proportion is now higher. So if you kind of go back and think about sort of like your normal curve, okay, so let's say that right here is where the 9.5% is, okay, we think that the percentage is now higher, and so we are going to test in this right tail. Hopefully that kind of makes sense from a visual standpoint, okay? All right, moving on to question B. In 2001, from a study, it was found college students study on average about 16.5 hours a week. Leading educators today believe that this average has dropped since 2001. So what is our null hypothesis? Okay, so what is the value that is currently believed to be true? Well, that is that the average is 16.5 hours. So don't use the symbol P, that's for a proportion or a percentage. The average is mu, and we're saying that the average is 16.5 hours. And since there are units here, do include them, okay? For means, we include our units. Our alternative hypothesis, so what is being said today by educators? Well, they think this average, again, has dropped, okay? The average has dropped. So in other words, they think mu is now smaller than 16.5 hours. In terms of what kind of a test this would be, this is going to be a left-tailed test because we are going to be testing that the mean is lower. So again, if you're going to set up what's going on here, and we have this average value in here of say 16.5 hours or whatever, we think now that that value is lower. We're going to test down in that range. Okay. All right. And next one, as a general guideline, drinking water should contain 3 parts per million of chlorine. A local council wants to test the chlorine levels on a sample of randomly selected days to see if they are in compliance. All right, so null hypothesis is that the average, again, this is an average, this is not a proportion, okay, there's no percentage there, so the mean is 3 parts per million, okay? They want to test the chlorine levels to see if they are in compliance. So not enough chlorine is bad because that isn't cleaning your water, but too much chlorine is also bad because that can poison you and make you sick. So they are interested in finding out if they are off the mark in either direction, not just on the high end, but potentially as well on the low end. And so whenever we have a test like that, we are testing that we are not equal to 3 parts per million. In other words, too low is bad, but also too high would be bad. Okay. This particular kind of test is what is known as a two-tailed test. Okay, a two-tailed test. We want to see if the mean has changed in one way or the other. So again, if we've got this 3 parts per million, we are looking to see, is it way too low down here or is it way too high up here? We want to go either direction, therefore a two-tailed test. Now, a couple of things that I can tell you as you go through this process, okay? The null hypothesis will always, 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 always contain an equal sign because we are saying, based on what we know or have always believed to be true, this is the percentage or this is the mean. That's an equal sign. The alternative hypothesis will always contain either a greater than sign, a less than sign, or a not equal to sign. If you are using any other symbols in either of those places, the null or the alternative hypothesis, you are doing it incorrectly. All right, in the next video, we will be looking at how we carry out hypothesis tests.